Welcome to this tutorial on collecting multi-digit numbers sent from the serial monitor to the Arduino using the while loop command structure and the inbuilt serial available function. Many people watching this video have probably already figured out how to capture single-digit numbers from the serial monitor, collect them, store them in a variable, and then have that variable enter into other parts of the code and trigger various events. But maybe all of them haven't, so we'll take a brief run through with this program. What it is a simple echo program. A single digit number or alphanumeric character is sent from the serial monitor to the Arduino. The Arduino does a conversion, converts it from the ASCII code to an integer, and then it prints that particular number back to the screen. So it's an echo program. So if I enter a 1 and click enter, it gives me a 1 back. It confirms whatever I enter. It echoes. And this is the first step in establishing numeric serial communication between the serial monitor and the Arduino. And it's a neat little program. It's nice. It does perfect. As good as one might hope for with single-digit numbers. But what happens if we want to send a multi-digit number, say the number 15, to the Arduino? What is this piece of code going to do? Well, let me reset the Arduino, create a restart, and so let's enter 15. What's going to happen? Well, oh no, it printed the 1 on a line, and then it printed the 15 on a line. I wanted number equals 15. It would do the same if I sent a big number. It strips that number into individual digits and then prints each one on its separate line, which is not what we want if we want to collect multi-digit numbers and then have the whole value to use somewhere else in the code. So this piece of code won't cut it. So how could we clean this up? And what additions could we make to this little piece of code to achieve the goal of collecting a multi-digit number, say 15 or 2015, and have that sent to the Arduino makes sense of it, store it in a variable, and then be able to use that number late in other parts of the code? Well, the first thing we can do is just a brief review what's going on in this particular code. Well, there is a number, it's of the integer type, it's a variable named number of the integer type that's assigned the value of 0. It doesn't have to be assigned the value of 0. It could just be initialized here rather than have an assignment. The code will still work, but it's always kind of nice, instead of leaving it hanging here, at this point the Arduino has set aside a block of memory that corresponds to the size allotted to the integer type variable, and there's a name attached to that block of memory, but the value could be anything left in those registers. We don't know what that value is. So in order to know what it is, all we have to do is assign it the value of 0. Now we know. And that's just good practice. Then we move from this global variable to void setup, and there's no mystery here. It's just a serial connection is established between the Arduino and one's computer, and there's a brief delay here. This just gives the connection time to stabilize, that the Arduino doesn't immediately try to start pitching these strings down the serial line. And it's only 50 milliseconds, but that's a lifetime in terms of computers and microcontrollers. So 10 milliseconds would probably be sufficient. But the next step is there's these serial print line commands. All they're doing is this escape character with the N. Some people may not be familiar with that, but all that does is say print an empty line and then print this string, and then the print line is going to print another empty line after this string. That's all this does, is prints an empty line ahead of where you are. You can use this escape character at the end too if you want to, and print an empty line and another one. Well, the next one, and this is just a simple user instruction to set the serial monitor to no line ending. Sometimes you need it on no line ending, sometimes on new line ending, and that's not clear oftentimes just by looking at the code. So it's always nice, once you figure out which setting you need, to go ahead and just send a brief string to the monitor to remind yourself or to remind your user what's happening. Is there a special condition I need to do before this program is going to behave correctly? Yes, in this case you need your serial monitor on no line ending. Otherwise you're going to have a new line character that goes through all of this and you'll get errant values. So the next thing is just a simple thing, enter a number. Simple user instruction. From the setup, we move into the void loop where the magic occurs. Number, that same number variable that we saw up here, is assigned the value of 0. Well, the first time through the loop, it's already going to have the value of 0, but after it goes through the loop, there may be some trash values that have collected, especially once we start sending large multi-digit numbers. There shouldn't be, but there may be. So it's always nice at the beginning of void loop, go ahead and establish that yes, number, we want it to have the value of 0 at this point. Then we have while serial is available or is equivalent to 0, do nothing. Well, what is this actually saying? That it's a while loop structure, and this is the while loop test. It's basically testing to see what is the return value of this inbuilt serial available function. It has a return value. That's what this is capitalizing on. The serial available function is inside the Arduino's serial receive buffer, where anything sent down the serial lines collecting in the Arduino. When that buffer has anything in it, serial available will return a number higher than 0. So what this is basically saying is while that buffer is empty, it's returning, which it will be returning a 0, this function will at that time do absolutely nothing. Well, that's good. And this has the nice advantage that given that it's in void loop and it's set here, that as long as there's nothing in that buffer, that void loop is not going to go past this line until we send something through the serial line. So now down to the next step is we have this while serial is available. This is slightly ambiguous in the way it's currently set up. Is that it depends. It's according to how familiar a person is with the way the return values of serial available works. That what this is saying is while there is at least 1 byte of data in the Arduino's serial receive buffer, while it's in there, execute this code. And if you could make that even more explicit by adding something like greater than 0 in there. I mean, we just saw that it worked without this comparative operator in here, but it's nice. Will it still work since it's been added? We can upload the code, just verify, and open the monitor and enter a single digit, and it should echo those single digits back. Yeah, it's still functioning. Nothing has changed as far as outward behavior goes. So this particular edition is not going to change the outward behavior, but it is a whole lot more explicit about what is happening here. Namely, whenever that serial available return value is something besides 0, which remember, if it's 0, it means there's nothing in the Arduino serial receive buffer. There are no bytes of data in there. Well, whenever there is a byte of data in there, the return value will be greater than 0. And then at that point, this test will be true, which will kick the while loop off and start the rest of the program. When this was out of here, we were just saying, well, whenever this is true, go ahead. So it's a matter of preference, but I tend to like to be as explicit as possible in the code, if it's possible to be. Well, after it gets into the while loop, what happens? Well, we have at least 1 byte of data in the Arduino serial receive buffer, so we want to read that byte. As soon as it's read, it's out of that buffer and it's gone, unless we assign it to some other variable. And in this case, we've created this one. We've initialized it as a byte type variable called incoming, namely the incoming byte of data, or the incoming data. Well, you could just as well have used the character type here. It would work too. Byte just is the way I think about it. There's a byte of data sitting there. So and it's up to you. But it's also kind of helpful sometimes to think about it in terms of a character, because it is a particular sort of character that's going to be received and read. It's not going to be just a simple int or integer. You'll mess up every time if you think it is. It's actually an actual ASCII version of a character, the ASCII code. So what happens is the first byte's read, it's stored in this variable, then we get to this point, and this is where that ASCII code, we're removing it or converting, pulling off the amount necessary to convert the ASCII type character that we've received from the serial monitor into an integer type variable. Number is an int, so it's going to convert the incoming byte, it'll be a single digit at this point, into a true single digit that's of the integer type. Now, how does that work? Well, there's tons of discussions of it. Ultimately, ASCII coding is 48 off of integer, and that's what the integer value of the 0 ASCII character is. So if you subtract this character of 0 or you subtract 48, it will convert whatever this number is into an integer equivalent, and then we'll dump it into a true integer variable. So that's just something. It can be a little confusing, but there's a lot of discussions on it. Then we take number, and then we basically print it to the screen. So once there's a byte of data in the buffer, the receive buffer of the Arduino, that byte is read. It's pushed over and assigned to this particular variable. This variable drops down. We subtract the necessary value to convert it into an integer, store it in number, and then we print number. It's echoed. So whatever comes in gets echoed back out. Now, as it sits, this isn't the best practices way to do this. For one thing, we could add this and add things to this piece of code and make it better. One thing we could do for sure that doesn't really, with a single digit, doesn't really make a lot of sense. But once we start pushing multi-digit numbers, it's always kind of helpful to make sure that that buffer is completely empty by the time we get to this point, because we don't want something to still be hanging out some byte of data in that receive buffer, because it'll immediately kick it through here. And we want it to be 0 and pause long enough for us to enter a multi-digit number, and then it read that particular number, not whatever trash values are in the receive. So the easiest way, one easy way to do that, there's always many ways to do anything with code, is we can say while serial available is greater than 0 at this point. So if there's a byte or multiple bytes of data still in the buffer, and after it's been all the way through the loop and rolled back around, then, well, what do we want to do? Well, we want to read that. So easy enough. All you'd have to do is say, let's see, yeah, as long as it's greater than 0, you just serial read. And then it's probably helpful to give it a certain amount of delay there. I mean, you can go 100 milliseconds, you can go a lot less probably, and it still probably work perfectly fine. But what this will do is, if there's any trash values collected in the Arduino's receive buffer, it reads them, but it doesn't assign them to any variable, so it just throws them away. It's basically, this is a flush. Serial flush flushes the transmit buffer. This will flush your receive buffer. These little lines of code, which is really helpful. So this is like serial flush for receive buffer. And it's really a good little piece of code to know and have on hand. So the rest of it's okay. This stuff here is perfectly fine. We can keep moving. But one thing about this piece of code as it currently stands is it doesn't really catch. What happens when a user enters like a letter? What is it going to do? Well, let's see. We can upload it, given that we modified it, make sure there's no syntax problems. The compiler will it'll catch most of them. So Now we were supposed to enter a number. Well, what happens if we enter a number? It's no problem. What if we enter the letter A? Oops, ooh, 49, what? Or if we enter the $sign. Oh, the -12, that's not what we expected. Well, that's because it's giving an ASCII equivalent to the letter A, or something, in the range. But now you got to keep in mind it's also subtracting over there that 48 from that letter A, and then 49 is the result. So you're not really even getting the ASCII equivalent to the character A. You're getting the ASCII equivalent to the character A minus 48, which is that 0 character. And in this case, this -12, well, that's just because that $sign had a really low ASCII value. It was a value that was below 48, and yet we subtract 48 from it, so the result is a minus number. So that's not really that great. So we can doll that up, make that a little better. So where would it matter? Where would we need to add some testing to eliminate the possibility that letters would actually be read into this stuff? Is we can do it right under the serial read. That's the best place to do it because we can test this incoming byte with just characters. We can say something like, if incoming is greater than or equal to the 0 character and its incoming, this will create two boundaries for it, is less than or equal to the 9 character. Remember, what's read in and stored there is a type of character. That if that's the case, then what do we want to do? Well, we'll do our conversions. But let's go with the else. First off, what happens if it's not a character digit? It's not a single digit character, 0 through 9. What do we want to do? Well, maybe we want to tell the user like serial print line, something like invalid entry. Try again. And that should be clear enough that the user, if they receive a message like that, they'll be like, oh, well, something not quite right here. Something went wrong. So we can throw an escape in there just to make a space. We may or may not need it, but it'll throw a space above this string. And, I mean, we can be doubly safe and clear out plenty of space. That'll dump 2 lines underneath it. One for the print line and one for the escape in. So that should work. And so this will execute if someone enters like the letter A or that $sign, etc., etc. It'll catch that and won't let it convert it and print it to the screen. So now what do we do? So we need to do that conversion. Here was part of the conversion, but at this point we want to collect and add on to our number. We want number to be assigned. But what we want is, say, number times 10 plus this incoming character, incoming minus the ASCII character of 0. And what will this do? Well, since we've added the incoming minus 0, this we won't need anymore. We can get rid of it. And what does this do? This is kind of confusing to people that come to this for the first time. Is they're like, okay, how does this exactly work? Because this is the magic. This is the magic of the multi-digits with while loops and serial available. It happens right here. So what is actually happening? Well, let's think about it. So if we scroll up just a little bit. If we go to the top of void loop, say that at first number's at 0, then we flush out the serial receive buffer on the Arduino, then it waits for a character. While it's waiting for a character, then we send it. Say that we send a 15, a multi-digit thing. We send a 15 here. Well, what's going to happen is it's going to pick up that first byte for the 1, going to read it, assign it to incoming. It's still going to be in ASCII format, and then but a 1 will be between the 0 and the 9, our boundaries. So it'll pass the if test. Then it'll be dropped down here and there'll be a 1 here. But it won't be 1, it'll be the character 1. And so, well, what is the equivalent of that? I have a sheet over here, it's 49. So if we send a 15, the very first character that's going to come through is a 1, and it's going to have the ASCII value of a 49 here. It's going to be just like this inside these little blue single quotes. It'll be 49. So it'll be 49 minus, this is a 48 value, so it'll be 1 will be left over. And then this is going to be added on to, well, whatever this is. Well, the first time through the loop, number is 0, so 0 times 10 will be 0. And so there'll just be a 1 left after this calculation is performed. That'll get assigned a number, and then it'll keep on trickling down. But we haven't closed this out yet. Like, we would not want it to print right at this particular time. If we did, it would print the 1. So we'd want to take that out. We'll need to put our print somewhere else. And we'll put our print after, see, the while, and this is the last brace of the while. We'll want to print here. Serial print line, number equals, and then serial print. We'll do a print line here with number, and then this will just be a straight up serial print, which that'll be good enough, because what it'll do is, I mean, we could even escape it out, put a space ahead of that if we wanted to, doesn't matter. But what'll happen is this while loop will repeat as many times as it needs to, and then when it has exhausted its what's in the serial receive buffer, it'll actually come down here, because this will turn false. And when there's nothing left in the serial receive buffer, the serial available will return a 0 value that will not be greater than 0, so the while loop will exit, and then it'll kick out our number right here. So, well, what happens? So say we're going back to that 15. The first pass through, we sent a 1. We put a 15 through the serial monitor. That means serial available is greater than 0. The 1 is read. The very first byte is read. It's pitched over here. It's in a character format, so it's really got the value of 49. And then, but either way, it's a 1 character, so it'll pass the if test. But its integer value, or what you might want to think of as its integer value, is 49. 48 will be subtracted from it, which leaves 1 here. Then that will be added to, well, 0. Number 0. 0 times 10, which is 0. So 1, and then number will be 1. And then it'll go all the way with this while loop, and it'll get down to the bottom of the while loop right here. And, well, the condition will still be true, because there'll be that 5 float, sitting right there at the edge of this Arduino serial receive buffer. And so the serial available will return a value higher than 0, which means the 5 will get read, assigned to incoming. 5 is between the 0 and the 9, but then 5 has its own ASCII value, which is 53. So we're going to have 53 minus 48, which just happens to be 5. And so it's going to be added, but keep in mind that number at this point has the value of 1. So 10 times 1 is 1. That 1 value gets shifted over 1 space, which is exactly what we want. And then 5 is added to it, which makes 15, which is assigned a number. Then it rolls back through, hits the bottom of the while loop, goes back up. Well, given that we put a 15 in there, it has read both of the bytes. As soon as it reads them, those bytes are pulled out of the buffer, never to return to it again. And so this will return a 0 value, which is less than 0. And this while loop will terminate, kicking it out to these print statements. And that's a little long-winded, but that's the play-by-play of what is happening here. So given that play-by-play, this should work. we should be able to put a multi-digit number into the serial monitor at this point once we upload this code, and it should echo a multi-digit number back. So let's upload it. No compiler errors, that's a good sign. I didn't leave off any parentheses. So yeah, just one last look. Okay, so now open the serial monitor. We get the same prompt and it tells us to enter a number, but this time let's start with 15. Ooh, what happened? Look at this. We've got a break here. That's not what we wanted. We wanted it to be on the same line. What is happening here? This is one of those gotchas with the Arduino. This is where, and it's not just the Arduino that this happens. I'm going to actually take this space out. I don't like that. But this is one of the gotchas. That what is happening is this is running so fast that serial available gets triggered, and that 1 in the 15 gets sucked in, passes the if test, gets converted, stored in number, and this is going so fast around that before it has a chance to, it's like before it can pull another serial read, pull the 5 in, it actually ejects. The while loop comes out, that serial available returns a 0 value. It doesn't have enough time to even recognize that there is something still in the buffer, and it ejects the 1 down here. So what we need is a brief delay. We need a delay that's short enough not to hang everything up, but long enough to give it enough time to recognize the serial available when it when it kind of pings the serial receive buffer in the Arduino. Give it enough time to recognize that there's a 5 sitting in the buffer. Simple to do, but something that is frustrating if you don't know to do it. So we can do a delay of 5 should work. 5 milliseconds. Just think about that. 5 milliseconds. That's a lifetime. Keep in mind to a microcontroller. So now, will it work? Let's see. All we've done is added a delay to everything. Just have one little 5 millisecond delay. So we need to enter a number. Let's enter 15. How about that? 15 shows up. It was just because the reason, and we can check this, put a larger number in there. Doesn't matter, just to show that it does work. It'll work. However many multi-digits up to, the only limitation is that we are using number is the int type. So we can't enter a number that's beyond 32,767. That's the allotted memory space for however many bytes of data it would take to make that particular number in the Arduino memory. That's as many bytes as we have that we can fill up. So, well, what does that mean in practical terms is that if we enter a number over, say, is 32,767 is the specification. So we should enter this and it should show. And it does, 32,767. But what happens if we go 32,768, which would be 1 over what the int type is, the memory allotted to the int type? Well, that was not good. I'll shut it down. Sorry. So 32,768, enter. Oh, look at that. It gives us 32,768, but it's negative. It rolled over. We see it rolled because the int is an unsigned. It's signed in this case. We haven't said that it is an unsigned integer. So that will determine how large of a multi-digit number will be legitimately accepted by an echo program like this, or any sort of program. You could take those. One thing to always keep in mind is serial print is just a way to say we've captured a variable from the serial monitor and we're doing something with it. You could be sending this number off to all kinds of other special purpose functions, doing all kinds of other things besides printing to the serial monitor. You could be controlling servo positions, you could be controlling the rate of motor speed, etc., etc. So don't think serial print's all this is good for by any means. But now let's think about that. What would happen if we just made this an unsigned int? In principle, that should double the positive numbers we should be, or non-negative numbers we should be able to enter into the serial monitor and it echo back. So upload this and let's check it. Remember, before we were only able to enter the 32,767. Well, what would happen if we go unsigned? It should be mostly double to that, so that would be somewhere around 6535. So that should print to the screen, and it does. The unsigned keeps it from going negative. It didn't roll over. Now, what happens if we go beyond this, which is the limits of an unsigned int? Well, so we could go 65,536, enter, and it goes to 0. See, we get a trash value that we exceeded the bounds of an unsigned int, which we can go bigger, though. There's nothing that limits us but that particular whatever we decide to type the number variable. So let's make it as big as we can. Say unsigned long. That's the big number in the Arduino microcontroller world. So let's upload it. And check it with a serial monitor. So the number that corresponds to, like the memory space that's been set aside for the unsigned long, should be able to store a number that's this size, 295. That should be as large as a number as we could enter into here. So let's see, does it print successfully? Yes, it does. That's the max, though. If we go one over that, so 42, 94, 96, 7296 instead of 95, let's go 96. What's going to happen? Enter. We're going to get another trash value. So that's as large of a number as we could do with this particular program, the way it's currently written. And we don't have anything else besides that unsigned long that would really be usable for us. So that's our limits. But think about that. That is, we could enter a number all the way from 0. So let's enter a 0. So we could enter the number 0 all the way to that gigantic number. And so that's a lot of multi-digit numbers to work with and to assign in code. And that's kind of helpful. But most of the time, you don't need it that much. Most people never need more than the int. I'm just going to go back to the int just for simplicity. But just know that you do have the unsigned int type. You have the long, and you have unsigned long. You could try any of those depending on your application, but you can exceed the unsigned long. That'll be the biggest number you can enter into the serial monitor and have this program pull it in and parse it. Otherwise, you'll be exceeding the memory to the types, and then you'll be getting trash values. So that being said, here's the program. It works. I mean, all we have is, I'll slow down so if anyone wants to pause the screen and record and copy any of this stuff. There's all that's happening. We've got one global variable. That's what's happening in setup. And then in void loop, there's the code. And really, the magic to it all occurs from this while down to the if, because there's where you're greater than while. This is where there's data in the serial receive buffer in the Arduino, and then this is the processing of it. So, but what about if we wanted to not have void loop junky like this with all the stuff in void loop? Couldn't we make just a simple special purpose function for this? Sure. So that we could call this multiple times if we wanted to. Say that we want to pull in a multi-digit number at one part in the code, do some other things, and then pull in another one later. That would be totally possible. Granted, it's just one multi-digit number we'd be pulling in at a time and processing and assigning, which there's other ways that you can do comma separated values. But at this point, let's just think simple. Pulling in one multi-digit number at a time. How can we convert all of this into a special use function that we could call multiple times? Well, the first thing we need to do is decide on what return type do we want that function to have. Well, it should match whatever the return type of number is, because ultimately that's what we're going to return what comes out of our special function into. We're going to give it back to number. So number's an int type, so let's just we need to be consistent with whatever. If you do unsigned long, the return type will need to be unsigned long. But for our purposes, I'm going to do int. Then let's just make a simple get multi-digit number function. We don't need any parameters, so we could leave this empty, or you can always go void, which means nothing here. If you put void in front of it, like with void loop, it's like it has no return value. And if you go void in the parameters, it means it has no parameters. So now we just close the function down. So what do we need to put in there? Well, we could put basically we wouldn't need this stuff in our function, but all the rest of it we would. So let's just take this stuff, cut it from void loop, and then paste it into our special purpose function. And now all we would need is, we've got this function, all we need to do is call it. So we can go to void loop and we could call this function. So get multi-digit number. We want to get the number, so call the function. And then what do we want to do? Well, this thing returns, well, and we haven't put a return value. So where do we need to put the return? Let's see, we just chase our parentheses. There's this, that's the while. So underneath it, right at the very bottom, before we hit the bottom brace of the function, we'll want to return what? Well, number. So let's return number. And this will take the updated value of number and send it outside of the function, so that we can, when we call it, we can catch that updated value with number and store it in number. And that, given that number is a global variable, this will work perfectly fine. This will run all of the code. The serial monitor, it'll take what's given from the serial monitor, process it out, pull off the ASCII stuff, convert it to an integer, and and keep adding on until it accumulates. That number that's here will eventually empty out the serial receive buffer on the Arduino, and whatever the number is by that time will get kicked out of the while loop. The while loop will go false here, the test will fail, it'll kick that number out, and that number will be grabbed and returned. Once it's returned, it'll be handed off to number, and then we can go serial print number, and we can get feedback again. So this should work. This should be a simple little special purpose function. So upload it. And check the serial monitor. Everything should still work exactly like it did before as far as outward behavior goes. So say I enter that number, it kicks it back out. I could enter others, doesn't matter. As long as I don't exceed that integer, it should be perfectly fine. And like I mentioned multiple times, if you want it to be able to enter larger multi-digit numbers, you just need to change the type of the number variable. Unsigned long will be as big as you can go, but if you change this type, you'll end up having to change the return type, change this to match whatever you change the type of number to, the number type variable to, and it will work. It'll continue to work. So that's just a way to create a little multi-purpose function. So you could do this. So say something you could do just to verify all this is, say the first number entered will be equal, and then you could call number again. So get, or you can call that get multi-digit number again, and then serial print the second number equals. and then number. And now we can run this function. So let's run this piece of code. And when it hits void loop, it should grab the first number we enter in the serial monitor, assign it to number, and then print that to the screen. Then it'll call the get number multi-digit number again, assign the value we've entered to number. Basically, it'll just overwrite, change the value of number, and then it should print second number. So let's see if that works, or if we need anything else. So the first number we can enter is, like, say, 1200. First number equals 1200. Say the second number could be 2536. Second number is 2536. Now what's going to happen if I enter stuff again? Well, it's in void loop, so it'll be the first number again. So 362 should be first number. It is 7845. Perfectly fine. Could be 10,000. It'll be back at first number. Yep. And see, so that's the beauty of having the little multi-purpose function. Every one of these function calls now takes some RAM and it takes some bytes, but at least it gives you the ability to pull in a multi-digit number in multiple places in your main void loop. And so you may have one set of instructions here, like doing blah with, you know, the first number, like number 1, and then here you could have a totally different set of instructions doing something totally different, doing blah 2 with the second number. I'm just using number 2 to mean second number. And that is the beauty of creating a little special purpose function. And the only tricky part to it is you've got to keep in mind whatever return type you're going to hang out front of your special purpose function, it's got to, you know, it needs to match whatever the type you've assigned to that number variable. You know, well, I mean, there's ways to work around that too, but the matching it is the most consistent way to go. So I hope this tutorial has been helpful of how to collect multi-digit numbers, one multi-digit number at a time. Granted, not the fanciest, but still very useful at times to people, especially if they're struggling to figure out how to do it at all. So I hope this tutorial has helped with this. There is, of course, more ways than just using while and the serial available inbuilt function to do this particular procedure. And then if people are interested in those, I'll be more than happy to do some tutorials about it. Until next time,